Let us understand how do we solve trigonometric equations within a domain of 0 to 2 pi, especially when we have something like sine nx. Means the number of waves between 0 to 2 pi could be 1, 2 or more. I am Anil Kumar. Welcome to my YouTube channel. We have thousands of videos for you arranged in playlist. Feel free to explore them for absolutely free. Now, here we have three different questions. One is sine x equals to square root 3 by 2. The other one is sine 2x equals to minus square root 3 by 2. And then we have sine 3x equals to minus half. Let us try to understand that when the argument is nx, then how do we get the required number of solutions within a confined domain of 0 to 2 pi? Let's begin with the very first question, which is sin x equals to square root 3 by 2. Now, when we say the domain is 0 to 2 pi, that means we are looking into the full circle, right? And we know using the cast rule that sine is positive in quadrant 1 and in quadrant 2. And therefore, we have a solution for this in our mind that there should be at least two solutions, right? One in quadrant 1 and the other one in quadrant 2. To find the solution, we can actually look into the special triangle where the sides are in the ratio of 1 to square root 3, right? Now, square root 3 is right opposite to the side where the angle is pi by 3, correct? So that means related acute angle is pi by 3, right? So this is a related acute angle. Let me write down here related acute angle is pi by 3. Now, whether we are looking into negative or positive, we should always find relative acute angle first and then the solutions, right? So now we have an idea that in this particular case, there are two solutions where the related acute angle is pi by 3. Means this is pi by 3 and that is also pi by 3. Related acute angle is the angle with the horizontal. And since the solution lies in quadrant 1 and in quadrant 2, the principal angle which we are going to write as an answer will be x equals to one principal angle being pi by 3 itself, right? And the other one being that much, pi minus pi by 3 or 2 pi by 3. You see, that is how we get two solutions for sin x equals to square root 3 by 2. Let us also understand this concept with the graph of sine function. The graph of sine function is, this is your sine wave, right? Now, it starts with 0, right? It goes to maximum at 1. And when we say that the value is square root 3 by 2, in that case, if I draw a line which is at square root 3 by 2, it intersects at two places. You understand? So those two are the solutions for the sine wave from 0 to 2 pi. Makes sense? So you can clearly visualize that the first two quadrants and the values, which are pi by 3 and 2 pi by 3, will provide you the right solution. Perfect. So that was easy. Now let's see how do we use this concept in finding when sine of 2x equals to minus square root 3 by 2, right? So let's use another page to get to this solution. So now the problem which we are going to solve is sine 2x equals to negative square root 3 by 2. So first step should be always find related acute angles. So we'll write sine alpha equals to square root 3 by 2. Now related acute angle means you are working in quadrant 1. It has to be positive, right? And so we know that alpha is equal to pi by 3. Many ways to know this, and the best is to use the special triangle as we took in the last case, where the sides are 1, 2, square root 3, and this right triangle pi by 3. Makes sense. So we know that the related acute angle is pi by 3 for 2x. Now, the other condition is we are looking at negative value, right? So negative means using the cos rule, we know sine is negative in quadrant 3 and 4, right? So we have the value here where the related acute angle is pi by 3. You see that? However, the answer should be always principal angle. Means you have to provide this as one answer and that as the other answer. But here's one more twist to it. What is the twist? See, the domain given to us is for x, right? So this really means that x is between 0 to 2 pi. But the question has an argument which is 2x. 2x means we are going to multiply each by 2. So it becomes 4x, 4 pi. So 4 pi means 2 circles, right? Even otherwise, if you want to see the sine wave, in that case, the sine wave, how many sine waves will be there within 0 to 2 pi? So I'm just drawing these sine waves just to show you that between 0 to 2 pi will have actually two sine waves. Since sine 2x will have two waves within 0 to 2 pi, and you can clearly see that square root 3 by 2 in this particular case will have four solutions, right? So we are having four solutions. But one circle will give you only two solutions. Now this is 2x minded. So you have to go once again and then go for a bigger circle. You get the whole idea, right? And so you get more solutions or exactly four solutions for this particular case. So now we know that this argument 2x should be equal to what? So 2x should be equal to, of course, pi by 3, 2 pi by 3. Sorry, one is not pi by 3. We are looking for minus square root 3 pi by 2, right? We're looking for sine 2x equals to negative. So we are looking into these two quadrants, correct? So the first angle here, the principal angle will be 4 pi by 3, right? So this is 3 pi by 3. So we have 4 pi by 3. And that one is 5 pi by 3, correct? So we have 4 pi by 3, 5 pi by 3. And then again, we are going to add to this 2 pi, correct? So what do we get? When you add 2 pi, which is or you can say that 2 into 3 is 6, right? 6 plus 4 is 10. So add 6 to it, right? So we get this as 10 pi by 3 to add 2 pi to each, right? So the other two are 4 pi by 3 plus 2 pi and 5 pi by 3 plus 2 pi. You get the whole idea, right? So that is what we are looking at. So 2x will mean two circles, four solutions. So it is going through 0 to 2 pi twice, right? So, well, so from here we can divide and then get the answer for x as equal to. When you divide by 2, you get 2 pi by 3 here, correct? Dividing by 2, you get 5 pi by 6. Now here, you are dividing by 2. So first you do this part, which let me rewrite this, right? 10 pi by 3 and 11 pi by 3. So when you divide by 2, you get 5 pi by 3 and 11 pi by 6. Makes sense? Because there's less space, so I kind of erased and rewrote it. I hope that makes sense. Right? So this is when we are looking into sine 2x equals to negative square root 3 by 2. We have solutions in quadrant 3 and 4, and that is how we are going to find all the answers. Now let's look into the last example where we have sine 3x. Let's see how do we do that part, right? So here is a fresh page for you. Sine 3x equals to negative half, right? So negative half. First we find the related acute angle sine alpha equals to half. And for half, we are going to use special triangle, right? 1, 2 square root 3. Sine is half of pi by 6. Correct. So we know that alpha is pi by 6. Now we are looking at negative, right? Therefore, I'll squeeze in this time so that we have enough space to work on. So pi by 6, negative means we are looking for answers in quadrant 3 and 4, right? So those are the solutions. So of course, one of them is going to be this and the other one is this, correct? So now let's write down 3x is equal to what, right? So 3x, because actual argument is 3x sine 3x is minus half. So if you go one circle, it is going to be 7 pi by 6 and 11 pi by 6. So we get 7 pi by 6 and 11 pi by 6. However, in 3x, what is happening? As far as the domain is concerned, domain was given to us as x between 0 to 2 pi, right? But if I multiply by 3, it will be 0 to 6 pi. Means 3 circles, right? 3 times. This really means that we have 3 ways 1, 2, and 3, right? And we're looking for half. Do you see this? We have 6 solutions. You understand? We are looking for half, 6 solutions. So you add 2 pi. So when I say add 2 pi, now when the denominator is 6, think like this. Multiply by 6 is 2 pi by 1, right? 12 pi by 6. You understand? So keep on adding 12 to each term. So, and you have to do it 3 times. So 12 plus 7 is 19. So write 19 pi by 6, correct? And 12 plus 11, 23. So 23 pi by 6. Makes sense? Now again, add 12 to this. So when you add 12 to this, 12 plus 19 will be 31, right? And 12 plus 23 will be 35. Makes sense? So it becomes easy. How do we add 2 pi? Now you have to divide by 3. So we get x equals to dividing each by 3. 3x is this, right? So 7 pi by 18, you can write 18 in the denominator. 11 pi by 18 19 pi by 18, 23 pi by 18, 31 pi by 18, and 35 pi by 18. You see, 35 pi by 18 is pi by 18 less than 2 pi, correct? So all these answers are within 0 to 2 pi. So I hope you have understood finally how do we work with this, right? So in general, if we have sine nx, nx, right? Sine nx equals to some constant, let's say half, right? In that case, how many solutions we have? We have two n solutions. Make sense? We have two n solutions. And that is the process of finding these solutions. So I hope this step is absolutely clear. In this video, we'll understand how do we solve trigonometric equation and provide general solution. To begin with, we have taken very simple example. The questions here are sin x equals to 0, cos x equals to 0, and tan x equals to 0. How do we find general solution for these equations? I'm Anil Kumar. Welcome to our playlist. It has thousands of videos, well organized playlist. You can practice and master the techniques. Let's begin with the very first question here, which is sin x equals to 0. Now, sin x, as you know, is a ratio in a right angle triangle where sin x is opposite side over hypotenuse. So if I form a triangle, let's say this is my right angle triangle, in that case, angle x being this, opposite side is right there, and this is the hypotenuse. For the sine ratio to be 0, the opposite side should be 0, right? So if this is equal to 0, that means opposite side of 0 length. And that is only possible if I reduce this angle to 0 itself, right? So we get one solution, which is x is equal to 0. So that forms one solution, right? But if you see the sine graph as such, then consider a point which is moving along a circle. In that case, you notice that there are two positions at which sine value is 0, correct? Now the coordinate point here is 1, 0, right? And here it is minus 1, 0. As you can see in these two positions, height of the triangle is actually 0, right? So you find that sine function is 0 at two places within the circle. If you sketch the sine graph, how will it look like? It look like something like this, right? Let me sketch it somewhere else. Instead of here, let me sketch it right there. So sine graph is something like this, correct? It is periodic, it repeats. Yeah, here also you could do it on the left hand side. You can see that it is 0 for theta equals to 0, theta equals to 180 degrees, and also 360 degrees, right? And so on. So what you notice is it is 0 for every multiple of 180, even minus 180. So the general solution should include all these points. Make sense? So we can write a general solution as what then? We can say x is equal to 180 times n, where n belongs to set of integers. You get an idea. So that is how we can write the general solution for the equation sin x equals to 0. Making sense, right? So we have seen it with three different ways, considering the triangle, considering the circle, and also the wave. Now, same principle will be applied for solving the second part of it, which is how do we find general solution for cos x equals to 0. Now, cos x, as you know, is in a right angle triangle, adjacent side over hypotenuse. If I want to make this as 0, that means the adjacent side is equal to 0, right? So, what does it really mean? Let's say we have some triangle here, right? So, this is the adjacent side, and that is the hypotenuse. The angle x is increasing if you move counterclockwise. As you move upwards, as you can see here, as you move upwards, and like this, we have a triangle which has got lesser adjacent side. The third one, very less, correct? So the cosine value decreases. Hypotenuse or radius of this circle remains same. So at this particular point, which is at 0, 1 for a unit circle, we have cos as 0, right? So cos is 0 at this particular point. Also, you will see if you further move on, the point which is right there, which is in this particular case 0 minus 1. There also the value of cos x will be 0, right? So the angles are, so this angle will be 90 degrees and this angle will be 270 degrees, correct? So we find that cosine function is 0 for 90 and 270, and then it repeats. It repeats means that if I sketch the cosine function, which normally starts with maximum, right? Of course, it is symmetric, you could do like this also. So in this particular case, you see that the sine function is 0 at these points, correct? And these points are at 90 degrees to 70 degrees. So odd multiples of 90, right? 90 times 1, 90 times 3, 90 times 5, right? So 450 degrees, and so on. So we can write a general solution that x is equal to what? X is odd multiples of 90 degrees, right? Now, how do I write odd multiples of 90 degrees? Odd means 2n plus 1, right? Of 90 degrees. You get the idea? Where n belongs to set of integers, right? So that becomes a general solution for cos x equals to 0, 2n plus 1, odd multiples of 90 degrees, right? So it is odd multiples, which is the expression 2n plus 1 of 90 degrees. Makes sense, right? So we have understood how do we solve this equation sin x equals to 0 and provide its general solution. Now here is the question for you to practice. You need to now write down the general expression for tan x equals to 0. I hope you are enjoying this journey of learning. Well, in case you want to learn directly from me, feel free to send an email on globalmathinstitute@gmail.com. Now, tan x equals to 0 means what? Well, we know that tan x is the ratio of opposite side over adjacent side. So, if I want this to be 0, means opposite side equals to 0, which is same as sine, right? Perfect, right? So, as we saw, for sine, we should have the same answer. Makes sense, right? Correct. So, those are the angles which are 0 and 180, right? So, on a scale, coordinate plane, those are the 2 points, which is 1, 0 and minus 1, 0, where tan should be 0. Well, it does make sense because you know what is tan x? Tan x is also ratio of sin x over cos x, correct? If I want this to be 0, means sin x is 0. So that also brings us to the same solution which we wrote in the very first case, right? So the general solution will be what? General solution will be, let's write down now, once again, general solution is x equals to, now this position is 180, right? And that is 0. So we can write 180 degrees n, right? Where n belongs to set of integers, correct? So that could be our answer for this particular question. I hope it makes sense. We need to find general solution of trigonometric equations. And you see, in all the three equations, we have tan x equals to d and e, where d and e means does not exist. Similarly, we have secant x equals to d and e, secant x does not exist, and cosecant x does not exist. Well, explore the playlist to understand better and get practice on similar questions. Let's begin with the very first problem, which is the value of tan of x does not exist. So, d and e. Couple of ways to look into this. One is we know that tan x is the ratio of sine over cos. And of course, cos x should not be equal to 0. Since you cannot divide by 0, so definitely the value of tan x will not exist when the x value will give cosine x as 0, right? So wherever if cos x equals to 0 means tan x does not exist. Makes sense, right? Simple as that. So the bigger question is when is cos x equals to 0, right? So we can look into the cosine function. The wave, cosine wave, is kind of like this, right? Periodic, it repeats. So at 0 it is 1. And you can see that cos x is not 0 at couple of points, which are 90 degrees, 270 degrees, and so on, right? If you're working in degrees. So let's write down here. So we know that cos x equals to 0 for x equals to odd multiples of 90 degrees, correct? So general solution means odd multiples, right? 90, 270, and so on, right? So we can write this as 2n plus 1. This gives you an odd number, odd multiples of 90 degrees, correct? Where of course n belongs to integers. N could be plus minus 1, plus minus 2, and so on. Those of you who are working in radians, for them we could write the same expression as 2n plus 1 times pi by 2 radians, right? Where n belongs to integers. So cos x equals to 0 at these points, and therefore the solution for tan x does not exist is the same, right? So it could be depending on you want to write in radians or in degrees. So you can write 2n plus 1 times pi by 2 or 90 degrees. So I hope that is absolutely clear. Great. Now what really happens at these points. We have a vertical asymptote, right? So let me also sketch a graph for tan x just to give you a better idea. It is kind of like this, right? Always increasing in its domain from minus 90 to plus 90, correct? So this is minus 90 degrees, that is plus 90 degrees, or pi by 2 minus and plus pi by 2, correct? And of course it repeats, so you could do like this, correct? So that is how you could visualize from the graph itself that tangent function does not exist for odd multiples of 90 degrees or pi by 2. Perfect. Now that should help you to answer part 2, question number 2 and 3 also. Let's look into question number 2 now, which is secant x does not exist. When will that happen? Well, that means 1 over cos x. Correct? And as we saw, those values when cos x equals to 0, right? Those are the answers. So we have exactly same answer here. So we can say x equals to odd multiples of 90 degrees, or it is 2n plus 1 times pi by 2, where n belongs to set of integers. Is that clear to you? Right. So if you want to sketch this function, you could always sketch it. First draw the cosine wave, right? Kind of like this. Right. There's a cosine wave. And when we want secant function, then at zeros, we have the vertical asymptotes, correct? You could continue on this side also, the left hand side. And the cosecant function will be like vertical asymptotes at pi by 2 minus pi by 2. Like this, right? So that becomes the secant x. So it does not exist at odd multiples of 90 degrees or pi by 2. Right, so that brings us to the last question, which is we want now cosecant x does not exist. Basically, 1 over sine x does not exist. So when is sine x equals to 0? That is what we need to figure out, correct? So as far as the sine function is concerned, let me sketch one wave here. Okay, we have repeated that wave. Zeros for sine are these, correct? So if we, let's say, start with the, let me start from here. And let's say this is like 0, this is pi, 2 pi, minus pi, like that. You may write 180 degrees, 360 degrees, and so on, right? Minus 180 degrees. So you can see that it is multiple of 180 degrees, right? So we can write x equals to 180 times n, or pi n, right? Or you can write n pi, where n belongs to set of integers. Make sense? So that is where cosecant x does not exist, right? So we have our solution, either one of them depending on which units you want to use. I hope it makes sense. Very important. Feel free to write a comment, share your views. If you like and subscribe to my videos, that'd be great. Trigonometry made simple. Let us enjoy this journey with Anil Kumar. Welcome to our series on trigonometry foundations. We are looking into general solution of trigonometric equations. Already we have solved 9 examples on this, and I hope by now you have the knack of doing it. Three more examples, consider them to be last in this series. Question number 10, sin x equals to minus square root 3 over 2 cos x square root 3 over 2 tan x does not exist. You can pause the video, answer, and then look into my suggestions. I am Anil Kumar. Welcome to my YouTube channel. We have thousands of videos for you to practice, explore the organized playlist to master these strategies. In case you want to learn from me, feel free to send an email on globalmathinstitute@gmail.com. Let's begin with the solutions now. So the very first one is sin x equals to minus square root 3 over 2. So we'll follow four steps. The first one is, where does the solution lie? We need to provide general solution, but again and again, in which quadrant are we going to come for the solution? Since sign value we are looking for negative, applying the cast rule, we know that the solution lies in quadrant 3 and in quadrant 4. Now, let's find the related acute angle. So we have sine of alpha equals to square root 3 over 2. Related acute angle is less than 90, so always look for the positive value. Square root 3 over 2 reminds us of a special triangle whose values are 1 to square root 3. Sine means we're looking at this angle, which is 60 degrees. So alpha, which is sine inverse of square root 3 by 2, is, if you're working in degrees, 60 degrees. If you're working in radians, pi by 3. So we got the related acute angle. Perfect. Now we need to provide a general solution for sine. Now look here, let's try to analyze this situation. Once again, have a look at it. We're looking for two solutions, one of them being right there, right, and the other one there, correct. Related acute angle is pi by 3, right? So it is not to the scale. So what we are trying to say here is that the two solutions are this and this, correct? So one of them is pi plus pi by 3 and the other one is 2 pi minus pi by 3. You get the whole idea, right? If you're looking in radians. For degrees, of course, it is 180 minus 60 and 180 plus 60. So this is the solution set which we are looking into the domain of, we can say 0 to 2 pi or 0 to 360 degrees, correct? We'll write the general solution. Just now, let's try to understand these two basic solutions first. So, of course, this is 3 plus 1, 4 pi by 3 and 5 pi by 3, correct. Now, in degrees, you could have written it as 180 plus 60, right? Or 360 minus 60. So that was in degrees. So that gives you 240 degrees and 300 degrees, right? So see, we found that what set of values really work in a normal domain of one full circle, which is 0 to 360 degrees or 0 to 2 pi radians. Now you know the solution. Can you write down the general solution? So let's make an attempt to write general solution now. So we can say x is equal to n pi. So when n is 1, then we are doing pi plus the related acute angle. So we'll do minus of minus 1 to the power of n and related acute angle being pi by 3. Do you see that? So that is how you could do. You can test your value. if n is 1, for example, then negative 1 to the power of 1 will be negative 1 itself. So it opens and give you n pi plus pi by 3. But if n is 2, then we subtract from 2 pi, right? In case you want to write in degrees, then it will be 360n, right? Sorry, 180n. Pi is 180. 180n minus of minus 1 to the power of n of the related acute angle 60 degrees. Does make sense? So that is how you're going to write the general solution for sin x equals to minus square root 3 over 2. Absolutely clear? Now let's take the next example, which is cos of square root 3 by 2. So cos x equals to square root 3 by 2. So when we look into the cos rule, cos is positive in quadrant 1 and in 4, right? So we are expecting solution in these quadrants. Correct. So clearly, if alpha is a related acute angle, we can write cos alpha equals to square root 3 by 2. Make a triangle. Just to visualize, the whole idea is to visualize, right? 1 to square root 3. So this is the angle. So we know that alpha is 30 degrees or pi by 6, depending on whether you're using degrees or radians. Is that clear to you? And you have the two solutions, right? So in case the domain was from 0 to 360 degrees or from 0 to 2 pi, this is unnecessary. However, just for those to understand the complete concept, I'm kind of repeating it. Then you can see we got two solutions. So within this interval, we have the solution x equals to the angle alpha, which is 30 degrees, and 360 minus 30, which is 330 degrees. Or you write x equals to pi by 6 and 11 pi by 6, correct? Okay. Now, maintaining our format, general solution will be what? As I was saying, x will be equal to, from here we have to add and subtract alpha. So it is 2n pi plus and minus alpha, which is pi by 6. Right? This is in radians. Or x equals to 2n pi is 360, right? 360 n plus or minus the angle here is 30 degrees, correct? Where n belongs to set of integers. Makes sense. So always write n belongs to set of integers. Last time we did not write, but included. Great. So I hope now these steps are absolutely clear. Let's look into the last question, which is tan x does not exist. You know the tangent graph, right? It is kind of like this, where we have vertical asymptotes at plus and minus 90 degrees, correct? So here we have minus 90 degrees and plus 90 degrees. So tan x does not exist for 90 and then 270 and so on, right? So few things are important here. First, we understand that tan has a period of pi. So you have to add pi, or we can say 180 degrees, correct? So tan has period of pi of 180 degrees. So we have to add 180 to 90. 180 to 90 means 2 times 90. So odd multiples of 90. So that gives you odd multiples of pi by 2, or you can say 90 degrees. Makes sense. So The function is discontinuous for odd multiples of pi by 2 or 90 degrees. So that helps you to write down the general solution, right? So let's write down the general solution. I hope you already got it. We have x equals to, if you're writing in degrees, it has to be odd multiples means 2n plus 1 of 90 degrees. If you're writing in degrees, it is again 2n plus 1 of pi by 2, where n belongs to set of integers. Makes sense. So that becomes a general solution for tan x not to exist, means a vertical asymptote as shown in the diagram. So does not exist is not a very common term, but I just use it. I hope you have enjoyed this journey of learning. Feel free to share your views and comments. If you want to subscribe to my channel, that'd be great. Thanks for your valuable time and all the best. We'll write down answers in both degrees and in radians. I am Anil Kumar. Welcome to my YouTube channel. You'll find thousands of videos which can help you understand the concepts and master the techniques. These videos are arranged in organized playlists which can further help you to focus on any particular topic. Explore and learn with Anil Kumar. Now, let's take up the solution of these questions one by one. The very first one here is sin x equals to half. Now, when we are providing a general solution, we have to see all possible solutions within the normal domain of 0 to 2 pi or 0 to 360 degrees. As you can see, we are looking for a positive value. That basically means that in a coordinate plane, for sine, if we write the cast rule, the solution should be in quadrant 1 and in quadrant 2. So that is where we are looking forward for a solution. So always first step is to find related acute angle. So we'll write down here sine alpha equals to the positive value, which is half. And we know alpha is sine inverse of half. And to find sine inverse of half, you can always use a special triangle. Calculator is not really required. And that gives you the value. Let me make one triangle here. This is the special triangle we were looking forward. 1, 2, square root 3. And this side will give you, this angle will give you side opposite as 1, hypotenuse 2. And you know this angle is pi by 6 or 30 degrees, correct? And so we have this solution as 30 degrees, or you can write this as pi by 6. So those are your solutions in degrees and radians in quadrant 1 for the given situation. Now second step is to write the solution between the interval 0 to 360 degrees, right? If you are working in degrees, or from 0 to 2 pi if you are working in radians. So we know now 30 degrees is one solution. The other one will be 180 minus 30, right? So we can say, well, x is equal to 30 degrees, or it is 180 minus 30, right? So that will be 150 degrees. That will be in degrees, or in radians. You can write pi by 6 and 5 pi by 6. One less pi by 6 than pi, right? So we get the solution which is from 0 to 360 degrees. So that is another step. The last step is to how do we write this as a general solution, right? That is what we are looking into. I'm taking this opportunity to walk you through all these steps so that things are absolutely clear. So, first step was to find the related acute angle, then all possible solutions within the standard domain of 0 to 360 or 0 to 2 pi, and then to generalize it means we know the sine waves are periodic, right? So, that is the sine wave, correct? What we are looking for, the value of half means, so all these points, right? All these points. Now, time period for one cycle is 360 degrees or 2 pi, correct? So, the general solution should be what? So, x equals to 30 degrees plus 360 degrees, correct? Or 150 plus 360 and every 360, right? So, 360 n, you get the whole idea. 360 n. The other one is 150 degrees plus 360 n. So these two become your general solution in the given situation, correct? You could always factor 30 in the first case and then write down a simplified version, correct? Similarly, you could also factor and write down a simpler case in the second one. Now, here when we write this, we say n belongs to set of integers because you could go counterclockwise when n is positive, one full circle, many circles for that matter, or clockwise when n is negative. Now, same thing if you want to write in radians, in that case, the answer will be x equals to pi by 6 plus every 2 pi n, right? Or this is one, right? The other one is 5 pi by 6 plus 2 pi n. So that becomes your general solution for sine x equals to half. Is that clear to you? In a very simple way. So I'm not really factoring and writing one expression. But you can get all these solutions from here. So I hope these steps are absolutely clear. We'll take up cosine function now. And I'll give you a general expression in a very concise way. So I hope the steps are absolutely clear. Let's move on to the next question, where we'll find the solution for cos of x equals to minus half. Now, cos of x equals to minus half means we are looking into coordinate plane. Again, think about the cos rule. Cos being negative means you are in quadrant 2 and 3, right? So that is where you have this value of minus half. And minus half also reminds you of a special triangle. You need not use calculator, where 1, 2, square root 3. So I prefer to make this 30, 60, 90 triangle, correct? And this angle, which is 60 degrees, gives you cos of half. So now from here, related acute angle, cos of alpha equals to half. Related acute angle means less than 90 degrees, and in quadrant 1, all are positive. So even if we want to find a negative half value, we have to find cos alpha as half, correct? Makes sense. So that gives you angle of, here in this case, 60 degrees, or you can say pi by 3. Perfect. So we have the related acute angle. Next step, as we saw earlier, is to provide all the solutions within the domain, which could also be written as 0 to 360 degrees or 0 to 2 pi. Both 0 and the boundary condition 360 or 2 pi is included when we write like this with square brackets, correct? So we are looking for two solutions. And you know this is 0, this is 180 or pi. So what you see here is that that is a related acute angle alpha, right? So what we notice here is that the answer is pi plus or minus alpha. You see that? Pi plus or minus alpha is your value, correct? So in this case, alpha, or you can write, we could write 360, sorry, 180 plus or minus 60 degrees, correct? So in general, that is the value which you are getting, correct? So in this particular case, let me just calculate this and figure it out. Let me write the degrees first, as we had been doing earlier also. So, so the angles here will be 180 plus or minus 60 degrees, right? Which gives you two values, of course, and one is 120 degrees and the other is 240 degrees, correct? So these are your two solutions, correct? So whenever you get this angle alpha, you can do pi plus minus alpha. If you're working in radians, then it is uh, pi minus pi by 3, which is, we'll write plus minus pi by 3. And so these two solutions will be 2 pi by 3 and 4 pi by 3. You get the idea. So you get the two angles for, these are the solutions for cos of x equals to minus half, right? So these are the x values. You get the idea. X value is the angle which we require. But this is not a general solution. Now, I'll show you a strategy of writing general solution in a very concise way, right? So we'll now think about general solution. Remember, the solution we just got could also be shown like this. We just found that the solution in this particular case is kind of like this, right? So this angle right there is what we're looking at as general solution. So this angle is 120 degrees, right? Now look here, you also notice that the angle from the other side is also 120 degrees, right? But this one is minus 120. Since you are going in the clockwise manner. So it is minus 120 from this location, right? Now, here is what every cycle ends, and the period of the cycle is 360, and therefore we can write the value of x as equals to 360n, right? Plus or minus 120 degrees. You see that how simple it is now? So in the last case, we were adding 360 degrees, but we can concise the whole solution right like this. Similarly, if you are working in radians, one full cycle is 2 pi, so we could write 2 pi n, right? Plus or minus. Now that is what we saw was 2 pi by 3, correct? So just one angle will work for you, right? So we get this as 2 pi by 3, where of course n belongs to set of integers. Do you see that beauty? So instead of making it more complicated, we could have written in this way also a general solution, correct? Now, the idea here is to find the related acute angle first and the actual angle, the very first one, which will give you the right answer. So, I hope that makes sense, right? Now, let's look into the general solution for the cosine for tangent function, the last one. Now, we are looking into tan of x equals to minus square root 3. So, tan is negative in which quadrants? Tan is negative in these quadrants. correct? You can use the cost rule. So we know the cost rule. We know tan is positive in quadrant 1 and 4, 1 and 3, but negative in 2 and 4. So we'll find tan alpha equals to square root 3. Special triangle, as you know, we had been sketching for all these examples, will again be sketched. So 1 square root 3, right? And 2. So tan is that angle, right? So alpha will give you 60 degrees or pi by 3, correct? So you know how to find this solution. Now the whole idea is to how do we generalize it? Now tan has a period of pi, correct? Tan has a period of pi. So you can see what really happens here is that to get to this value of negative, we'll find two solutions first. So we say what is x equals to? Now we are trying to solve this equation tan x equals to minus square root 3. So x is equal to within the domain 0 to 360 degrees, let's say, or 0 to 2 pi, right? So within that domain, we have two answers. One you can see is right there, right? And the other one is this, correct? So these are the two solutions which we are looking into, right? Now the first one here is because the angle is 60 degrees acute angle, 120 degrees. The other one here is you will also write minus 60 degrees, right? Or you write 360 minus 60 or 300 degrees. As far as the radians are concerned, the angles will be 2 pi by 3 and 5 pi by 3. So these are the two solutions within 0 to 360 or 0 to 2 pi. But our interest is to write a general solution, right? So for general solution, let's look at it in a different way. We have two solutions right there, where that is the angle alpha, right? So what really is happening is that from pi you are subtracting alpha, and from 2 pi also you are subtracting alpha to get the answer, correct? So every cycle you're subtracting the related acute angle alpha. Now in our case, alpha was this. So related acute angle in degrees was 60 degrees and radians was pi by 3. And therefore, we can now write down the answer x as equal to n pi minus alpha, which will be pi by 3. Or you could write this as n times 180, which is 180n, minus the angle alpha, which is 60 degrees. You see that? So that becomes a general solution for tan x equals to minus square root 3. So I hope you got the idea of how do we write a general solution when the trigonometric equation is given in a simplified form. Now this is very useful since even in a factored form, you will get to this stage at the end before writing your answers. So once you understand this, you can actually write solutions in general for any trigonometric equation. I hope it makes sense. Feel free to write your comment, share your views. If you like and subscribe to my videos, that'd be great. Thanks for your valuable time and all the best.